Hello students, myself Shaji Tandon from Chemistry. Today I am here with the class 8 topic. The name of the topic is Combustion, Flame and Fuel. In this video, I have explained each and every point of the chapter in a very simple and interesting way. Apart from the information which is required for class 8 level, some extra informations have also been included in this video which are very much required for your various competitive exams. Before starting, I request you to please subscribe my channel, like this video and share the video with your friends. So now let's see what we will study today. In this video, Combustion, Flame and Fuels, we will study about different kinds of fuels. After that, we will study the difference between burning of a candle and burning of a coal. After that, we will study chemical process of burning and the type of flames produced during combustion. After that, we will study the burning of magnesium ribbon, charcoal and coal. Then we will see what is combustion. After studying combustion, we will discuss about fuel. After that, we will study about combustible and non-combustible substances. Then finally, we will see conditions necessary for combustion, and all these points will be supported by various activities also. So, first of all, we will see what type of fuels are used for various purposes at home, in industries and for running automobiles. So children, if I ask you to give examples of fuels which are used in for various purposes in homes, in industries and for running automobiles, you have numerous examples. So some of the examples I am mentioning here, definitely you will name following fuels like petrol you can name, LPG you can name, LPG, CNG. Then you have wood, charcoal, coal, etc. So you have a lot of examples for fuels which are used in homes, in industries and for running automobiles. Now we will see the difference between burning of a candle and burning of coal. A candle burns with flame, whereas coal burns without flame. It simply glows. So we can conclude that some fuel burn with flame and some burn without flame. After that, we will study about the chemical process of burning and the type of flame produced during combustion. Children, you know that whenever a substance is burnt in air, it usually produces heat and light. This is a common observation that during burning of a substance, heat and light is usually produced. So, we will see burning of a magnesium ribbon. So, children, in your previous classes, you must have seen the burning of magnesium ribbon in the laboratory also. So what happens when a magnesium ribbon is burnt? I'm just writing the chemical equation. The symbol of magnesium is Mg. So when magnesium ribbon is burned, the burning takes place in the presence of air. So air consists of oxygen, and children, oxygen is the supporter of combustion. So Mg plus O2, what will be the product form? Product form will be magnesium oxide. So as we are writing here, the symbol of oxygen gas is O2. This reaction is not balanced. So what we will do? We will write 2 MgO here and 2 magnesium. So during the burning of magnesium ribbon, what happens? Magnesium burns with oxygen and produces magnesium oxide. The name of the substance produced is magnesium oxide. Apart from this, light is also produced. I'm just writing here plus light. I can write here magnesium oxide plus light. So this is the chemical reaction which takes place during the burning of magnesium ribbon. With the help of this diagram, I'm showing you the burning of magnesium ribbon. Children, magnesium burn with a dazzling light. During the burning of magnesium, during the combustion of magnesium, dazzling light is produced. And this experiment must be done under the supervision of supervision of your teacher with proper eye protection. That is very much required here. Now we will see the burning of charcoal. Children, charcoal's chemical composition is C only. So during the combustion of a charcoal, what happens? Charcoal burns with oxygen. And what is produced? CO2 is produced. Apart from CO2, heat is also produced. In the case of magnesium, we have seen that dazzling light was produced, and during the burning of charcoal, heat is produced. Children, charcoal is produced by the destructive distillation of wood. So how charcoal is produced? I'm just writing here, charcoal is produced by destructive distillation of wood. So a question must be arising in your mind, what is destructive distillation of wood? So charcoal is produced by destructive distillation of wood. So I want to explain you what is destructive distillation of wood. Children, when wood is strongly heated, in the absence of air, it converts into charcoal, whose composition is carbon only. So during the burning of charcoal, we have seen that heat is produced. And during the burning of magnesium, just now we have seen that light was produced. I'm underlining this light here. Here I am underlining the heat. After that we will see the burning of coal. Children, coal's chemical composition is also carbon. So when coal is burned, the carbon present in it combines with oxygen, and what is produced? CO2 plus heat is produced. CO2 is carbon dioxide. So again we can see here, during the combustion of coal, heat is produced. So we can conclude that during the combustion of a fuel, what happens? Either heat or light is produced. So what is the common things in all these type of process, in all these type of combustion, all these classes, burning produces heat and light. So we can write here the common thing in all these cases of burning is that heat and light is produced. So this is the common thing, heat and light. We can write here heat and or light. Heat and or light is produced during the process of burning. Heat and or light is produced during the process of burning. So that was the common thing in all these cases of burning. After that, we will study what is combustion. So children, the combustion, just now whatever cases we were studying, actually that was combustion. So how can we define combustion? The process of burning of a substance in the presence of air or oxygen. So we can write here the process of combustion is the process of burning of a substance. The process of burning of a substance. In the presence of air or oxygen. In the presence of air, or we can say oxygen, because oxygen is present in air only, with the liberation of heat and light. With the liberation of, with the release of heat and light. Heat and light is called combustion. So this is the definition of combustion. So combustion is the process of burning of a substance in the presence of air or oxygen to produce heat and light. And light is produced in the form of flame or glow. That also we can mention here. Light is produced light is produced. In the form of flame or glow. Light is produced in the form of flame or glow. After that, we will study what is fuel. So children, the fuel is a substance that undergoes combustion, and it may be solid, liquid or gas. You know the various examples of solid, liquid or gaseous fuels. So solid fuel, you can say coal, charcoal, wood, etc. So I can write here coal, charcoal, wood. If I talk about the liquid fuels, you can say here liquid fuel is we can write here alcohol. We can write here petrol, kerosene, etc. And if I talk about gaseous fuel, so children, many hydrocarbons which exist in gaseous state, they act as a fuel. For example, liquefied petroleum gas mainly consists of LPG. I'm just writing here LPG mainly consists of butane gas. So LPG, the main composition of LPG is the butane gas. And for storing LPG in cylinders, it is stored by compressing under very high pressure. So that's why it is converting into liquid state. So it is called as liquefied petroleum gas. The main combustion of this is butane. Then what is the fuel for our body? Children, daily you are doing a lot of activities. So it's quite obvious that for doing these activities, definitely you require energy. So from where you get this energy? What is the fuel for your body? So food is the fuel for your body, children. What is the fuel for your body? Food is the fuel for your body. What is happening? How do you get energy from this food which acts as a fuel in your body? In our body, food is broken down by the reaction with oxygen and heat is produced. So children, this process is actually the process involved during the process of respiration. We take oxygen gas. We inhale oxygen gas during the process of respiration, and during the process of digestion, the food was converted in the form of glucose. So formula of glucose is C6H12O6. So after different processes of digestion, the digested food is converted in the form of glucose. So C6H12O6 is the symbol of glucose. It combines with, it undergoes combustion with oxygen which we have taken, which we have inhaled during the process of respiration. So what is happening? You can see the process of combustion is taking place in our body also. So what will be the product formed? 6 molecules of CO2 will be formed plus 6H2O will be formed. Along with that, the energy will be produced. Heat energy will be produced. So we can write here energy, heat is produced plus heat. So this is the process which is taking place during the process of respiration in our body. The heat energy is produced which we are utilizing for doing our various processes, and CO2 which is formed here is exhaled during the process of respiration. So at this point, I hope this point is clear to you. After that, I'm just going to discuss about combustible and non-combustible substances. Children, first I want to share a list with you. After that, we will try to define combustible and non-combustible substances. So combustible substances are the substances which burn easily. So I have a table here. With the help of this table, I want you to find out what is a combustible substance and what is a non-combustible substance. So what do you think? First example here is wood. So wood is a combustible substance because it burns, it undergoes combustion. Then paper. You know that paper also burns easily. So paper is also a combustible substance. What about iron nails? Iron nails are non-combustible substance. They don't undergo combustion. Then kerosene oil, it's a combustible substance. What about stone pieces? Stone pieces are non-combustible substances. Then straw is a combustible substance. Charcoal is a combustible substance. Matchstick, again it's a combustible substance. What about glass? Glass is a non-combustible substance. So this answer you are giving from your daily experience. There is nothing deep knowledge is required here because all these points you are observing in your daily life. So now I am just coming to the topic combustible substance. So children, what are combustible substance? Combustible substances are those substances which burn easily. We have various examples with us. For example, we have paper. Few examples I'm writing here. Paper we have. Kerosene we have. So these are the petrol, paper, kerosene, LPG, etc. All these are the examples of combustible substances. A few more I can write here, LPG, CNG, etc. So in this picture you can see that various combustible substances are shown here. Then again in this picture we have the examples of few more combustible substances. You can see this is LPG is here, kerosene is here, coal is here, wood is here. All these are the examples of combustible substances. Then we will discuss about the non-combustible substances which don't burn in air or oxygen are called as non-combustible substances. We have various examples of non-combustible substances like we have glass, we have iron nails, and few examples have been shown in the picture also. So sand is an example of non-combustible substance. Stone is an example of non-combustible substance. I hope these points are clear to you. Children, after that I want to discuss about the conditions necessary for combustion. This is a very important point and interesting as well. So children, what are the three conditions? There are three conditions which are necessary for combustion. First thing is the presence of a combustible substance. Second is the presence of supporter of a combustion. And third required condition is the attainment of ignition temperature, or it is also called as kindling temperature. So we will discuss all these three conditions one by one in detail. So first point is the presence of a combustible substance. Children, this is a very important point and this is quite obvious that if a combustible substance is not there, combustion will not take place. So presence of combustible substance means a substance which undergoes combustion must be there. So I'm just writing here a substance which can burn, which can undergo combustion, or which can burn. Must be present, must be there. So that is the condition which is very much required there, because tons of oxygen you have, but if a combustible substance is not there, then process of combustion will not take place. Then second requirement is there, second condition is there, presence of a supporter of combustion. Children, this is a very important point. Presence of supporter of combustion is very much required here. So what is the supporter of combustion? A substance which help in combustion of a combustible substance. So I'm just writing here a substance which helps in combustion of a combustible substance. A substance which helps in combustion of a combustible substance. Is called as supporter of combustion. So substance which helps in combustion of a combustible substance is called as supporter of combustion. This thing we have seen. Then what is the supporter of combustion? We will see air or oxygen, because air consists of oxygen. The oxygen which is present in air is responsible for combustion. So air or oxygen is supporter of combustion. Air or oxygen is. Supporter of combustion. Then, one point we have to keep in our mind that for the process of combustion to take place, a sufficient amount of supporter of combustion is required. If oxygen is not there, if air is not there, the process of combustion will not take place. The process of combustion will stop. So I can write here adequate amount of sufficient supply of supporter of combustion is required. Sufficient amount of or sufficient supply of supporter of combustion is essential, is must. Sufficient supply of supporter of combustion is must for the process of combustion. Is must for combustion. If the supporter of oxygen is not present in sufficient amount, or if it is not present in sufficient amount, or if it is not there, then what will happen? The process of combustion will stop. So I'm just writing here sufficient supply of supporter of combustion. So what I said, if sufficient amount of supporter of oxygen is not present, or air is not at all present, then the process of combustion will not take place. Now children, this is an experiment I just want to mention here with the help of these three sets of experiment. So I just want to mention here, I just want to explain what is this experiment. Children, in this experiment, we have taken a lighted candle. We have fixed a lighted candle on the table. So this is a lighted candle. After that, we will put a glass chimney over the candle. And in the first case, you can see here we have the few wooden sticks. So in the first case, so what we have taken a lighted candle first. After that, we placed a glass chimney over it. But in the first case, the glass chimney was placed over the blocks of wood. In the second case, the lighted candle was placed directly over the table. Means it was not placed over the blocks of wood. And in the third case, the glass chimney was covered with a piece of cardboard. So what will happen? What do you think, children? What will happen here? As I told you, these are the three conditions. In the first case, you can see that from the bottom we had wooden. What is this? We can write here, these are the blocks of wood. So we have blocks. In the first case, we have blocks of wood. Both sides you can see that we had blocks of wood. But in the second case, blocks of wood were not there. So what do you think? What will observe in all these three cases? What do you think? Does the flame flicker off? Does it flicker and give smoke? Or does it burn unaffected? This you have to think. So you will find that in the first case, what will happen in the case A? Where air can enter the chimney from the bottom, the candle burns freely. In the first case, where the air goes from the bottom, the candle burns freely. But in the case B, where air doesn't enter the chimney from below, because there is no space here for air to enter from the below, the flame flickers and produces a smoke. You can see here. What is this? A smoke is produced here. The flame flickers and smoke is produced. What will happen in case C? Children, you can see that in the case C, the flame finally goes off because the air is not at all available. So in the third case, no air. Air is not at all available. So what will happen? The flame goes off. So I hope this experiment is clear to you, children. Quickly, I just want to re-explain the experiment. You can see here in the first case where air can enter from below, the candle burns freely. But in the second case where the air cannot enter freely from below, the flame will flicker in the second case and produces a smoke. But in the third case where air cannot at all enter, the flame finally goes off. So with the help of this experiment, we can conclude that for the process of combustion, the presence of supporter of combustion, which is air or oxygen, is very much required. Whatever points of this experiment I have explained just now, I listed here in these two slides. Then the same thing is being explained here. We have taken a lighted candle. Once we put inverted glass, transparent glass on over this inverted candle, we can see that in the second case, you can see here the candle and the flame turns off. The flame turns off because supporter of combustion is not there. So children, I hope this point is clear to you. And you might, in the third case, you can see that all of you have seen, all of you know that you might have heard that when the clothes of a person catch fire, the person is covered with the blanket. What is the reason why you are covering the person with the blanket? The reason is that the clothes of a person have caught fire. So, if you are covering that person with the blanket, you are going to cut off the supply of oxygen. So that's why what will happen. So to cut off the supply of oxygen, to cut off the air supply, air or oxygen, the blanket is wrapped around a person whose clothes caught fire. So this observation also explains that the supporter of combustion is very much required for the process of burning. Then third point, children, we were discussing about the essential conditions which are very much necessary for the process of combustion to take place. So first point was, what was the first point? The first point was supporter of combustion. That was the first point we have discussed, that was the combustible substance. So we have seen that for the process of combustion to take place, a combustible substance must be there. If a combustible substance is not there, the process of combustion will not take place. And what was the second point? The second point was the supporter of a combustion, which is air or oxygen, must be there. And the second point we have proved with the help of activities also. Now we are coming to the third point. What is the third point which is required, which is very much essential for the process of combustion? The third point is the attainment of ignition temperature or kindling temperature. So children, a question must be arising in your mind that what is ignition temperature? What is kindling temperature? Children, remember that the lowest temperature at which a substance catches fire and starts burning is known as ignition temperature, or it is also called as kindling temperature. So what is kindling temperature? What is ignition temperature? Is the lowest temperature at which a substance catches fire. Okay, so if that lowest temperature is not reached, the substance will not catch fire. Remember this thing. So the fuels which have very high ignition temperature, which have very high kindling temperature, they can be stored safely at room temperature. But the substances which are having very low ignition temperature, we have to take extra care to store them. So every substance has its own ignition temperature. That is another important point you have to keep in your mind. So now we will discuss, based on these points, we will study what are inflammable substances. So children, inflammable substances are those substances which have which catch fire easily. So some substances have very low ignition temperature. If they have very low ignition temperature, as I told you just now, that they can catch fire easily with a flame. So such substances are called as inflammable substances. So what are inflammable substances? The substances which have very low ignition temperature and can catch fire easily are called as inflammable substances. So I hope this point is clear to you. After that, I would like to mention some examples of inflammable substances. So first example is the petrol here. So first example is the petrol, children. The petrol is written here. So what do you think about petrol? All of you have seen that the ignition temperature of petrol is very low. So that's why petrol is highly inflammable substance. We have to take extra care while storing the petrol. You must have seen in the petrol pump the cautions are given. Then one more substance I want to discuss here. This substance is white phosphorus. So children, this white phosphorus is having ignition temperature only 35 degrees Celsius. So you can imagine that if its ignition temperature is very low, only 35 degrees centigrade. So what do you think about its storage? As the ignition temperature of white phosphorus is very low, what will happen? It will catch fire easily. Some more combustible substances are like CNG, LPG, alcohol. All of these substances have very low ignition temperature. So that's why they catch fire with a flame, and they are called as inflammable substances. So all these are the examples of inflammable substances. We can write here, all these are inflammable substances. They are highly inflammable. Then I have few points here to discuss with you. Children, a matchstick, kerosene, petrol, wood or coal, they can't catch fire on their own. What is the reason why they can't catch their fire on their own? The reason is that their ignition temperature is more than the atmospheric temperature. So I'm writing here, their ignition temperature is more than atmospheric temperature. Atmospheric temperature means I'm talking about room temperature, children. So if their ignition temperature is lower than the atmospheric temperature, what will happen? They cannot catch fire. A substance can catch fire only if its ignition temperature is, what will happen? If its ignition temperature is lower than the atmospheric temperature, then it can catch fire. So this point, I hope this point is clear to you, because the substances whose ignition temperature is higher than the atmospheric temperature, they will never catch fire on their own. All of you might have seen, or you can discuss this thing with the parents, with your mother. What will happen? They will explain you that cooking oil catches fire when a frying pan is kept for a long time on burning a stove. So what will happen? I just want to explain you this point. When a frying pan is kept on a flame for a long time, what will happen? The cooking oil catches fire. The reason is that the cooking pan has become very hot. And when you pour cooking oil into that, it will help in attaining the ignition temperature of cooking oil. So it catches fire. So high temperature, I can write here, the high temperature of pan helps in attaining the ignition temperature of oil. Then, one very important point I want to mention here, children, kerosene oil or wood, they don't catch fire on their own at room temperature. All of you might have seen. If you have not seen, you can discuss with your parents also that kerosene oil or wood don't catch fire on their own at room temperature. But if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it won't catch fire. So what does it mean? What you can say that? We can conclude on the basis of this statement that whose ignition temperature is lower? Can you guess? So yes, I think you are guessing correctly. Ignition temperature of kerosene is lower. Ignition temperature of kerosene is lower than the ignition temperature of wood. So that's why. But both of them, kerosene as well as wood, their ignition temperature is more than the atmospheric temperature. But if you heat a little, kerosene oil will catch fire. But wood will not catch fire. So what is the reason that the ignition temperature of kerosene oil is lower than the ignition temperature of wood? Now, so this is the statement which we have just discussed just now. Okay, ignition temperature of kerosene oil is lower than that of wood. So we need a special care for storing kerosene oil. Not only kerosene oil, all the inflammable substances like petrol, like kerosene, like diesel, we need to take a special care for storing them. Children, here we have one activity. So in this activity, I just want to explain you this activity. We have taken 2 paper cups. So they are 2 paper cups. These 2 paper cups you can make simply by folding the paper. By folding the paper, you can make 2 paper cups. So by folding paper, we have prepared. So one of the paper cup is filled with water. You can see here in one of the paper cup water is there, but one of the paper cup is empty. Here you have no water cup, no water. This is empty paper cup. Now what you are doing, you are putting these 2 paper cups, one is having water, one is without water, another one is empty. You are placing them on the candle flame, but you have to take very extra care. Don't perform this activity alone. You must perform this under the guidance of some elder person. So what you will observe that once you start heating, what are you thinking? In the case of the paper cup where water is there, the water will start boiling and the paper will not burn. So what is happening here, children? The heat which you are supplying to the paper is transferred to the water by the process of conduction. So it means the ignition temperature of water is not reached, because whatever heat you are supplying to paper, it is transferred to water by the process of conduction. So because of this, ignition temperature of paper is not reached, so paper won't burn and water will start boiling. But in the second case, what will happen? In the second case, as water was not there, once you are heating it, the supplied heat will bring the ignition temperature of paper, so paper will start burning here. So here you can see that in this case, paper will not burn. Paper cup won't burn. But in the second case, what will happen? The paper cup will burn here in the second case. I hope this activity is clear to you. You understood it. Children, what we are studying the third conditions, which is very much required for the process of combustion. The third condition was ignition temperature or kindling temperature. So children, always remember that for a substance to burn, or for a substance to undergo the process of combustion, it is very much required that its ignition temperature or kindling temperature must be attained. So the same activity which I have discussed is explained here in these two slides. So children, I hope all these points are very much clear to you, whatever I have discussed with you. On the basis of these points, I would like to discuss some questions with you, children. Our question is that in combustion process, energy is, what do you think? Four options are given to you. Energy is required. That is the first process. A point, energy is required. Second thing is energy is released. Yes, children, you know that energy is released in this process. So this point is correct. First point, you know that energy is not required here. Then third is wrong, neither required nor released. First is also wrong. And fourth point, none of the above is also wrong. So what is the correct answer? Answer B is the correct. In combustion process, energy is released. Then the second question. Burning of magnesium ribbon in air produces a dazzling light. It shows. It is a chemical process. Children, what do you think? Yes, it's a chemical process because I have shown you the chemical reaction also. A chemical change is taking place. What is formed here? 2Mg plus O2 will give you 2MgO. So a new substance is formed. That's why it's a, what do you think? It's a chemical process. So this MgO, I'll write in a proper way. I think it is not clear to you. So I'll write it again. MgO. So first point, it's clear to you that yes, first point, it is a chemical change because a new substance is formed. Because a new substance is formed, so that's why it is a chemical change. Then, magnesium is combustible. Yes, of course, magnesium is combustible. That's why the process of combustion is taking place. Oxygen is required in the process. Again, you will very confidently say, yes, oxygen is required in the process. Because without the presence of oxygen, which is a supporter of combustion, the process of burning will not take place. So, what is the final answer? D. All these points are correct. So, this option is a correct option. Then, next question. If ignition temperature of A is more than B, the rate of combustion is higher for children. I want to mention one point here. The ignition rate of combustion is inversely proportional to ignition temperature. Higher the, so I'll just write here with a using a different pen. I'll write here, different color pen, rate of ignition is inversely proportional to ignition temperature. I mean to say, higher the ignition temperature, lower will be the rate of ignition, rate of combustion. I can write here, rate of combustion. So this point you have to keep in your mind that rate of combustion is inversely proportional to ignition temperature. So whose ignition temperature is more? Ignition temperature of A is more than the ignition temperature of B. So where the rate of combustion is higher. As the ignition temperature of A is more, it will take more time. And ignition temperature of B is lesser than A. So the rate of combustion will be higher for B. Children, did you understand? I just want to explain it again. Since the ignition temperature of A is higher, so A will take more time for combustion. So B will take less time for combustion. So rate of combustion is higher for B. Then third point is both A and B. This is the wrong answer. None of these. This is also a wrong answer. So correct option is the option B is the correct option, children. Then So one point I want you to always keep in your mind, I have written here rate of combustion because in the question they were asking rate of combustion. So always learn this point that rate of combustion is inversely proportional to ignition temperature. Then I want to discuss next question. Next question is the fire extinguisher cuts the supply of air. How they cut the supply of air? They cut the supply of air either by spraying water or by using the fire extinguisher which supplies CO2 gas. That also will cut off the supply of air. So what will happen? If the supply of air is cut down, it brings down the temperature. Yes, it brings down the temperature because if oxygen is not there, combustion will not take place. Combustion will not take place, heat energy will not be released. Heat energy is not released, so the temperature will be brought down. Then it stops the supply of water. No, this is not the correct answer. It stops supply of water. There is no question of this point. Stops the supply of fuel. No, fuel was already there. The fire extinguisher is only trying to cut the supply of air. If the supply of air will be cut down, what will happen? No combustion, no release of heat. So what will happen? The temperature will be, it brings down the temperature. Brings up the temperature, absolutely wrong answer. Stops the supply of air, absolutely wrong the answer. So the correct option is option A. So children, whatever we have discussed here, I hope each and every point is clear to you. So we have studied today different kinds of fuels. After that, difference between burning of a candle and burning of a coal. After that, chemical process of burning and the type of flames produced during combustion we have studied. Then burning of magnesium ribbon, charcoal and coal we have studied. After that, we have studied about combustion, what are fuel, then combustible and non-combustible substances, and finally we have studied about the conditions necessary for combustion with the help of various activities also. So children, I hope that you like this video. Each and every point of the video you understood nicely. So thank you so much for watching this video. Children, if you have any doubt, post your doubts in the comment box. Please subscribe my channel, like this video and share the video with your friends. Don't forget to watch my next video. Thank you so much. Have a nice day.